How's it going, everyone? This is Brian, and welcome back to the Tech Stack Playbook, your guide to apps, software, and tech, but in a fun way, I promise. So, have you ever wanted to build your own chat GPT or a large language model? This is something that has just absolutely shaken the internet. Everyone is talking about AI and machine learning and large language models. And of course, we're thinking, what's a large language model? And you see the LLM in everything: LLM, AI, ML, LLM again. And what are these technologies? What is everybody talking about? So, in this build, we are going to be building our very own large language model. We're going to be using Meta AI, which is a part of Facebook Meta companies, and what they created was their own large language model called LLaMA, and they have a second version out now, so it's called LLaMA 2, and this is one of the most comprehensive large language models available to us. But before I keep saying large language model and LLM, let us actually deconstruct what a large language model is. So, a really easy way to think about it is if you think about a box of Legos. Legos are going to be little bits and pieces of information that make sense about the world. So they're just little pieces of information. They might be rules, they might be facts, they might be anecdotes. They're just little pieces of information or data. Now, when you think about having many of these Legos just thrown into a box, they don't really make sense. They're just sort of thrown around. They maybe have a little bit of order, maybe a little bit not. Maybe it might be ordered, by size or by how they connect together, or maybe certain types of pieces are next to each other. But other than that, there isn't really a structure if you were to just look at the box of Legos. Now, what you would want to do is that if you wanted to build something, you're going to be putting these Legos together in a way that makes sense. So when you ask a large language model or an AI model a question, what the LLM is going to do is that it's going to reach into this box of Legos and create an answer that most aligns with the pieces that answer your question. So if you ask a question about a specific type of food, it's going to then go into the Lego box and it's going to start putting together these different Lego combinations of what you just requested in terms of information. And it's going to use a deep neural network to be able to find the right information to help service your answer. And this is something that is very, very, very complicated, but it is made really easy to use with apps like ChatGPT, Google Bard, and Hugging Face Chat. So what's amazing is that a lot of these technologies are now available to us where we can now start requesting information, asking very complicated questions, and then these huge large language models will reach into that box of Legos and then structure an answer that most aligns with the similarities in the data that answer your question. So again, like if you ask a question about food, specifically, a chocolate dessert, it's going to then go into its record of Legos and then pull in what it thinks you might be interested in related to a dessert that has chocolate in it. Now, let's say that you ask about a street light or a street lamp or something like that. Now it's going to be searching the Lego box for something completely different, and it might be thinking about the size of the something related to the street light or the street lamp. It might be looking and trying to find out maybe some rules about it, but it's going to have its own sort of treasure trove Lego box that it's parsing through and searching through so that it can deliver you the right answer. And these technologies are very, very, very fun to use as well. And of course, when we think about these large language models, how could we build one on our own? So fortunately for us, we can create a ML ops pipeline that can service a ChatGPT-like endpoint, but we don't actually have access to ChatGPT and their AI models because those are all closed source. So Meta AI created their own version of a large language model called LLaMA, and it's partly closed source. You can request access to it, and then you can be approved, and then you can have access to use the model. So it's not exactly closed source, but OpenAI is completely closed, so you can't actually access the model. You can only use their API endpoint, or make API calls to their API. So what we're going to do is that we're going to have our very own endpoint running with our model that's deployed within Amazon SageMaker. And this is really exciting because this is then bringing a lot of those very technical AI topics into our AWS account so that we can use them whenever we want. Or we can use them for different products, different services, for our own use cases. So this is going to be really exciting, and we're going to dive into all of everything from the build. So this is going to be start to finish, how to build and deploy and then service your own endpoint for LLaMA 2 on AWS. So if you're ready for this exciting build, let's get started. To give some context about what LLaMA 2 is, so I'm on the Meta AI website. So it's ai.meta.com/llama. And this is a little bit more about the model. So if you look more into it, what we're basically providing is a large language model that is semi-open sourced, and they're calling it the next generation of large language models. So what this is a pre-trained and fine-tuned LLaMA language model ranging from 7 billion to 70 billion parameters. So those parameters, again, are those Lego blocks that we were talking about earlier. And when you have, in the billions of information packets, this makes the model even more powerful. So just a little bit about it. So it was trained on 40% more data than their first version of the LLaMA model and has double the context length. So what we're going to be doing is we're going to be going through the 13 billion parameter version, and it was pre-trained with 2 trillion tokens, and the context length was 4096 in terms of the model architecture. And then in terms of data collection for helpfulness and safety, supervised fine tuning was over 100K, and human preferences was over 1 million. So they say that it's been fine tuned for chat use cases and that the model has been pre-trained so that we don't have to do that. So this is what's going to allow us to work right out of the box with this model. And this is a little bit more about just the benchmarks that they were evaluating their model from. And they also have LLaMA Chat and Code LLaMA. So just a little bit more about it. But overall, a heavily powerful large language model that we can work with. One of the other components of this MLOps pipeline is using Hugging Face DLCs, otherwise known as deep learning containers. Now, these DLCs are pretty interesting because Hugging Face has a great partnership with AWS. So what DLCs allow within SageMaker are what it says right here. So I'll zoom in and I'll show you. So it talks about Docker images that are pre-installed with deep learning frameworks and libraries for transformers, datasets, and tokenizers. So this is what it's going to allow us to start training models, right from the start. And we don't need the complex processes and optimization patterns of training environments from scratch. We really can just plug in these DLCs, and as Docker images, we're able to then run these models in our pipelines within SageMaker. So they're particularly helpful because they have a pre-written serving stack, and it also just drastically reduces the technical bar of needing to do, deep learning serving and running, the model, really all of the parts of it by yourself. So that's great. And DLCs are available everywhere that SageMaker is available. We're going to be using Amazon SageMaker, so this will be able to run within our SageMaker environment, within our Studio UI. And we don't really need to use the SageMaker Python SDK, but there will be some elements where we'll be using this SageMaker Python SDK, which you'll see in this build. So other than that, there's other benefits to using SageMaker, which we'll discuss, but it's cost effective, it has built-in automation, and a lot of security parameters that are a part of the build. So for example, encryption at rest, in transit, running VPCs for connectivity. So you could run your SageMaker within VPC, and also IAM to ensure that how you're accessing the model and data and technology around it is secure and safe. So this is really great, and Hugging Face is amazing because they provide a lot of these awesome features and benefits that we'll be using with Amazon SageMaker. And before we get started building with AI and ML on AWS, something that I personally like to do is look at the AWS blogs, and I try to learn more about what has already been deployed, what has already been created, and then see what the experts have learned from that process. So there was a really great blog post about the foundational models for Meta that are available within SageMaker Jumpstart. Highly recommend checking out SageMaker Jumpstart in case you haven't already set that up. You will need to request access within the Amazon Management Console, but you'll be able to do that very easily, and then you'll be able to start using this as a service. They have many different models that have already been set up to run within SageMaker, so you sort of just click a button and then you're able to just deploy that within SageMaker, which makes it really easy. But in our build, we're going to be doing it more manually, which might be helpful too, just to give you a perspective of what it looks like to build a model in case it wasn't in Jumpstart, but just to know these models are available within Jumpstart as well. So one of the helpful tables that they shared in this article was this. So they showed all of the different models that are available. So the 7 billion, the 13 billion, and the 70 billion. And you'll notice that it either has, something billion or something billion chat. And we're going to be using this one, which is the 13 billion chat. Now, something to note, of course, is the type of model, the max tokens that you can use, and this, which is their recommended default instance type. So what this is MLG512 X-Large server. Now, when we are thinking about deploying something, one of the tools that we're going to want to search for is the Amazon SageMaker price calculator. So I was searching on that in Google, and I arrived at this page. Now, let's say that we hadn't heard of this type of instance before. So we're going to be clicking that. We're going to go to the Amazon SageMaker pricing tab, and then we're going to search for this. Now, what we'll notice is there is a certain virtual CPU, there's a memory, and then there's price per hour. The price per hour is going to be really important, and we see that this is not necessarily the most expensive, but it's certainly not the cheapest. And this is billing at $7 an hour. Now, something that we're going to really need to think about, and I cannot stress this enough, is that when we're building, a model, or we're having something that's going to be running in real time, we really need to think about the cost here, because if you just leave this running, you're going to be running $7 an hour for a whole day, so 7 times 24, and let's actually get a calculator up so that we can map some of this together. All right, so let's see this. So this is $7 an hour, and let's say that it's running, all the time. So this is like an always online endpoint or something like that. So each day it's going to be billing $170, per day, which is, that's something to think about. And then if you are running this for a whole week, you're looking at almost $1,200. Now let's say that we're running this for 4 weeks. Now you're looking at almost $5,000 a month. And then let's look at the year. You're looking at about $57,000. So this is a model that is very complicated. It has a lot of different components. It is immense. And we really need to think about, first of all, do we have the budget to run a model like this? Are we willing to put up costs to bear this? And also, what is the output? What is the business model? There's going to be a lot of considerations that you want to think about. So I just say that as this technology is very exciting, but sometimes costs can be kind of put to the wayside, because we're building exciting technology. So I just want to throw that out there, that this is going to need a very expensive server to run. And you will just want to make sure that if you're building this and it's running, it's going to be running a cost. So if you wanted to, run this for a few hours, right? You do $7, an hour. That won't be as bad as if you had it running in the evening. So something that you could do to optimize would be to, we'll deploy the endpoint, but then you could maybe take it down and then reuse it. Maybe what you could do is you could store the endpoint name or the ARN of the endpoint inside parameter store, and then you could be referencing that inside of your application so that you're able to refer to this endpoint, and the ARN might be changing, but it'll always be connected to an endpoint that is live because you might be switching out the ARN, or if there's no ARN available, then the function won't run or something like that. So just something to think about, where when you're running, again, a model of this type, you would be needing to run this type of server, and it can get costly. So just be very cautious and careful that you don't leave this running longer than you can afford to and longer that you need it to run, just so that you can save costs. Now, the first step for us to get started with deploying LLaMA 2 on Amazon SageMaker, we're going to go to our Amazon Management Console, and we're going to type in the search bar SageMaker, and we'll go to SageMaker. And I already have some domains set up, but what we could do is we could set up a new domain, which we'll do. So what domains basically are is that, and it explains it in here, but it says that it's an associated Amazon Elastic File System, EFS volume. So it has a list of authorized users, has a variety of security rules and policies, and a virtual private cloud configuration. So each user in a domain receives personal and private home directory within the EFS for notebooks, Git repositories, and data files. So this is sort of your home base for deploying a model, or working with different notebooks and those types of things. So what you could do is that if you create a domain, they have a quick setup, and then they have a standard setup, which is 10 minutes. So the quick setup, 1 minute, can't beat that. And what we'll do is that you'll get a domain name. So you could choose that yourself. So we'll call this LLaMA 2. We'll call this prod. Now, under the user profile, instead of default, we'll just call this LLaMA 2 prod. And then we'll give this some characters. And then in terms of the execution role, so this is the default execution role for users and spaces in the domain. And this, it needs to have Amazon SageMaker full access so that it can do a bunch of activities. But what we're going to do is that we're going to create a new role. And what we're going to do is that we're going to allow any S3 bucket. Now, this is when we're creating this role, we're using IAM to provision the access to AWS. So this is important to make sure that you're not giving access to SageMaker beyond what it really would do. So if you knew the specific S3 bucket that you would want the domain to select, you would want to go back into this role once you create it, and it will either specify it before you create the role, or you can always update it. So you want to use ARNs to delineate which S3 buckets you want to give access to. But this is just important just to note that this is just going to give access to any S3 bucket in the account, which is fine because we're going to be tracking all of the buckets that we're using and those types of things. So we'll create role. And this will just take some time for it to provision this within IAM, within our AWS account. So now what we do is we have now this new execution role. So that was created here, and that was already appended as the execution role. So this will be the execution role for the domain. And we're also going to enable SageMaker Canvas permissions just in case we need to. It's just going to give it Amazon SageMaker Canvas full access and some of these other roles that let us use Amazon SageMaker Canvas if you want to use that. And have a cool series of videos on using SageMaker Canvas with AWS. I'll link that in the description below so that you can check that out in case you want to see what SageMaker Canvas is all about. So when we do submit, we currently have more than one VPC. So what we're going to do is that we're going to choose one of these VPCs. And in terms of the subnet, we'll choose 2 subnets. And we'll save and continue. So now this is going to submit it. And now it's going to be configuring the quick start user that we just created, which was the LLaMA 2 prod with those numbers. and the resources needed by this domain. So this might take a few minutes for us to get set up here, as it's going to provision the domain for us to then start plugging away with SageMaker. So I'll turn the video back on when this is all finished setting up. So now that our SageMaker domain is set up, what we can do is that we can go to the Launch tab and launch this. So we can click on it, and we get more information about our domain. And if we click on Launch, we'll be able to launch Studio. We could do Canvas, TensorBoard, Profiler, or Spaces. We're going to choose Studio. So we'll click on this. And what it's going to do is that it's going to redirect us to our domain. And this is a SageMaker domain we just set up. And now it's going to run Amazon SageMaker Studio. So it's going to spin this up, and this is going to be creating a Jupyter Server application for running Jupyter Notebooks, terminals, anything that we need to run models and AI inside of Amazon SageMaker. So I'll come back once this is finished. This will probably take about 3 to 5 minutes, maybe 7 minutes for this to spin up. So I'll come back when this is all logged into SageMaker Studio UI. So we see that this is loading. So what we can do is that once it finishes loading, we now see that we're logged in. We have our LLaMA 2 prod user, and they're logged in. This is our personal studio, and now we're in SageMaker Studio UI. So this is great. So what we're going to do is that we are going to open the launcher, and we're going to create a notebook. And what we're going to do is that the notebook and compute resources we're going to use are the MLT3 medium. We don't have any startup scripts yet. We're not going to be configuring that in this video, but if you wanted to set up your own startup script, you could do that. And we're going to be using Python 3 and Data Science 3.0 image. So we'll create a notebook. And what this is going to do is that this is going to start provisioning that notebook kernel. And to just give a little bit of an explanation here. So when we have a running kernel session, now we could also have a terminal session running. We could also have a running app, and we could also have just running instances in general. So whenever you are launching a notebook, you're launching a terminal, you're launching anything that is running within SageMaker, you definitely want to go to this tab to make sure that what you provision, you basically turn down those resources when you're not needing to use them anymore. You get billed by the hour, of course, from the pricing calculator, which we looked at earlier. And we just want to make sure that we're not going to be incurring extra costs related to running these notebooks, these instances, these sessions when we're not using it. And especially if you close out the tab of SageMaker, that does not mean that these terminals or sessions will stop. They'll still be running and they'll still be billing. Now that can be helpful if you maybe need to close out of SageMaker and come back to it, and you don't want to have to rerun everything all the time. But if you start having a lot of these sessions running at any given time, you're just running extra compute costs that you don't need to. And it'll just be running up your AWS bill. So your wallet probably won't like that either. So we'll just wait for the notebook kernel to finish starting up, and then I'll switch back the video on when it's ready for us to start coding. All right, so now to the fun stuff. So this is where we have our IPYNB. So our Python notebook is ready to go, Jupyter Notebook. And you'll see that we have our running instance here, which is running on the MLT3 medium instance. And we also have a running app, which is the running app for our notebook. Cool. And then we have a kernel session here, which is running on that instance. So now what we want to do is that let's just kind of do a little bit of documentation here. So the overall scope is we want to set up LLaMA 2 on SageMaker. Okay. So what we're going to do is that we're going to first set up dependencies. So also one of the things that we can do while we are installing the dependencies and stuff is go to the request form for LLaMA 2. So it's going to be ai.meta.com/resources and then models libraries and then LLaMA downloads. So you want to fill out this form and you have to agree to terms of it. But basically what you're going to want to do is you're going to need to request access to LLaMA, and you're going to need a specific access key. And what you're going to need to do also is set this up from within Hugging Face. So the email is going to need to be the same. And what that means is when you go to Hugging Face, you're going to want to go to Meta LLaMA, and then this is the verified Meta LLaMA organization, and then it has information about LLaMA 2. Then when we go down to the specific build that we want, so we're going to want 13 billion, we're going to want chat. So click on this. So then you will see something here where it says you need to request access. So the account that you set up on Hugging Face, on huggingface.co, this is going to need to be the same email that you request the Meta LLaMA 2 model. And that's really important because this is how they're verifying it. Because what you're going to do is you're going to use an access token from Hugging Face to then prove that you have access to read from this deployed model that is within Hugging Face. So with that access token, it's going to need to be the same email so that it can be verified on the back end when Meta verifies you. So just something to keep in mind there. So when you request that form, you'll be able to start basically getting into the approval process, and probably by the end of you doing the dependencies tutorials, you probably will have access to start using that model. So what we're going to do is that we are going to install the SageMaker Python SDK. So what we can do is that we'll do pip install SageMaker, and then we'll do upgrade and then quiet. And also we're going to save this file, so we'll just call this deploy LLaMA 2. Cool. So then we'll run this. And I'm also running this for anyone that's new to Jupyter Notebooks. I'm doing Shift and then Enter. So sometimes you may get some errors. So we can sort of see maybe what's going on here. And if you ever get like an error or something like this, something that you could do is you could do pip list, and then you could do grep and then SageMaker. So seems like it's already installed, but something that we could do, just if we wanted to check, we could try to write this again, because it didn't work. Could do pip install SageMaker U. Try that one more time. Cool. And then we can see if that actually changed the version. That was like 2.182. Yeah, so it was already installed by default, but just in case you ever get that error, do pip install SageMaker. Cool. So now what we can do is that once we can list that, we know that this is a part of the install dependencies. Now we want to make sure that SageMaker is set up with IAM and the right libraries. So what we're going to do is that we're going to do a few things. We're going to check the IAM role for SageMaker, which is the context explanation. We're going to import libraries like SageMaker and Boto 3. We're going to establish a SageMaker session to interact with SageMaker resources, and we're going to set up a SageMaker session bucket for our model. We're going to obtain an execution role. We're going to configure the SageMaker session with the bucket name if it's available to us, and then we're also going to tell us the information about the SageMaker role ARN and the session. So we're going to write a script to do all of that. So what we're going to do is that we're going to do some import statements. We'll do import SageMaker. We're going to import Boto 3. We're going to import NumPy. We're going to import SciPy. Okay, now what we're going to do is that we're going to declare SageMaker execution role variable globally. We're going to do that with SageMaker execution role, none. And we're going to set this in the script so that we'll be able to reference this at a later point in the Jupyter notebook. So just know that we'll be using this in a little bit. Next, we're going to set up the SageMaker session. So what we'll do is that we are going to find a function. We're going to call that set up SageMaker session. And this is going to pass in a default bucket, which will be set to be none. And then we're going to add some information. So this is going to be set up SageMaker session and get IAM execution role. Next, for parameters, this is going to be default bucket. And this is the default bucket name to use for the session. And this is going to return a session, which is a SageMaker session object, and then the role ARN. And that's going to be the ARN of the IAM execution role. Cool. So then for our global variable, which is the SageMaker execution role, we have our session, and that equals SageMaker.session with a capital S, default bucket, and that equals default bucket. Cool. Then we'll do a try except, so SageMaker execution role. We'll do SageMaker.get execution role. Cool. And then in the except, there'll be a value error. And this would be an IAM photo3.client IAM and SageMaker execution role equals IAM.get role name equals SageMaker execution role. And then pull out role, pull out ARN, and then we're going to return the session SageMaker execution role, as we'll need them in a little bit. All right, so then in the next function, what we're going to do is that I'm just going to make sure that when we are logging our account, something that you might want to do is that just to parse out the account number, so that if you do log and share a Jupyter notebook, you might just want to have asterisks for the username. So we're just going to write a function to mask the account ID. So we're going to define a function called mask account ID. That's account ID here, and then we're going to return an asterisk multiplied by the length of the account ID. So however long it is, add an asterisk. Then we're going to define our main function, and that will be SageMaker session bucket equals none, and this is going to you'd set your default bucket if desired. Otherwise, this is going to make a bucket for us later. So then we'll pass in session SageMaker execution role equals setup SageMaker session default bucket and equals SageMaker session bucket. And then basically we're going to do the mask. So we're masking the account ID, and then it's going to turn the 5th segment into asterisks. So something that looks like that. So we're going to say account ID equals SageMaker execution role, and then split. And they're separated by that colon. And then we want the 5th item, which is the 4th index. And then we're going to do masked account ID equals mask account ID with ID, and then masked role equals SageMaker execution role. And we'll just replace that with our masked account ID. And we're going to be printing 2 things. We're going to be printing the ARN with that masked role, and then we're also going to be printing the session for our SageMaker instance. So SageMaker session region, which we will need for later. So session.photo region name. That looks good. And then if name equals main, then run main. All right, so I'll give this a save, and we'll give this a go and see if this runs. So seems like, oh, default bucket. That should be a underscore. Try that again. Cool. All right, so we have our execution role here, and we have our region here. So this seems to be good so far. So we'll give this a save. And then we're gonna move on to step number 2, which is obtaining Hugging Face LLM DLC, which is that deep learning container. So it's a little bit bigger, and I will hide that just so that we can see this a little bit easier. So what we just did was just to kind of go a little bit step back. So we installed SageMaker Python SDK, and then what we're doing is that we are creating basically this SageMaker execution role as a global variable, and then we're setting up the SageMaker session so that we'll be able to then start tracking some of these values and be using them when we are using SageMaker. So now what we're going to do is we are going to now be obtaining the Hugging Face LLM DLC. This is that deep learning container that we talked about in the beginning of the video. So now in this part, what we're going to be doing is that we're going to retrieve a container URI, which is a uniform resource identifier, and that's going to help us find this DLC using the SageMaker Python SDK. And then this URI is used to specifically find that Docker image when creating the Meta LLaMA 2 model that we're going to use, which is the Hugging Face model. So what we'll do is that we're going to, from SageMaker.HuggingFace, import get Hugging Face LLM image URI. And what we're going to do is that we're going to fetch Docker image URI for the LLaMA 2 model which is really the Hugging Face DLC. So there's going to be two params that we need. One is the backend name, and then number two is the Hugging Face DLC version. So those are the two parts. So we're going to say that this is our LLM image, and that's going to equal get Hugging Face LLM image URI. And then we're going to pass in two things. So Hugging Face, and then version equals 0.9.3. Cool. And then we're going to log Docker image URI that we are obtaining. So what we'll do is that we'll do print, we'll do f LLM image URI, and then pass in the values LLM image. Give that a save, and then we'll try to run this. All right. So now we see that this is getting this large language model image from Hugging Face, which is, this looks like it's in the Elastic Container Registry, and it's under Amazon AWS, Hugging Face, PyTorch, TGI Inference, and it has GPU, and Ubuntu, and this looks like PyTorch inference configuration. Okay, so this is great. So this is the exact container that we're looking for, and I've already deployed this type of model before, so this is a image URI that is familiar to the last time that I deployed this. So now what we're going to do is that we are going to now determine the model requirements. So we've already figured this out in the most part. So let's make this as a new section. Okay, so in terms of what we know that we need, so we know that we're going to need that ML G512 xlarge instance. We know that we are going to need that because the blog had specifically talked about that. We know that we're going to need the meta LLaMA 2 model. So we need to have request form fulfilled, approved, and we need Hugging Face account so that we can get that model, and then we'll also need the access key. So those are some of the model requirements that we're going to need to get this live and running. Now what we're going to want to do is we're going to want to confirm the correct SageMaker instance requirements are met. So what we'll do is that we're going to start writing a script to check that. Great, so we're going to say with, and then we'll say open, opt, ml metadata, resource metadata.json as f, and then metadata equals json.load.f, and then print metadata so we'll run this, and this did not like that, so let's see why. So it says JSON, so that's fine. So perhaps we need to import JSON somehow. Cool. So when we're able to do that, we now see that this is the instance that we have currently running, but this is not running on that 12x large instance. So what we're going to need to do is we're going to need to switch our instance here. So what we might need to do is give this a save. we'll need to switch up our instance type. So G512X large. So we're going to need to probably spin this up. We might not need to do that right now, but if you want to switch it now, it might make sense to do that. So when you switch to this and you select it, you might need to go to the resource section of AWS, and there's resource or service quota, and this is where you could request access to this. So you might not have access to this specifically, but you'll need this specific type of instance. So we'll do select, and this is going to restart our notebook, and we'll need to reinstall some of the scripts. As some of the ones we won't need to do that, but for other ones we will need to do that. So we'll just wait for the notebook to set up, and then we will go through this whole thing, and we just want to make sure that this is going towards that G512X large instance. And again, if you get an error because you're trying to run this, or it says like you are at capacity because you're not allowed to have one or something like that, you'll just need to go into the AWS Management Console and go request the access to that specific server instance. So if you do need to request access because you're getting an error, it says something, like you're not allowed, a certain instance, or you're not able to deploy something. So what you're going to do is that you're going to go to your AWS Management Console, you're going to go to Service, and then go to Service Quotas. And then there's a specific section of the Management Console. You go to Services, and then SageMaker, and then it has all these different basically resources and stuff. So, you might have things like Canvas apps running on this type of instance, maximum number of concurrent auto ML jobs. There might be something, so we could try to search for G512X large. So for example, you might have the number of apps running on this type of instance. Applied quota, you might have it as 1, but the default quota might be 0. For example, for this, when you have the for endpoint in usage, this was really 0, and I had to request to have it be more than 0, so I requested it to be 5. So this is something that you could do, but what you would do is that you would go into here, and then what you would do is that you would go here, and then you scroll down, you would request a quota increase, and then you could see current utilization, and then the applied quota value. So then if you wanted to say like 10, for example, you could request that and then do a request, and then to be able to file that gets created as a ticket, and then it'll go to support for somebody to help you get access to the resources that you need. Switching back to our Jupyter Notebook. So now I have switched out the instance. So now what we're doing is we're running on this G512X large instance. We'll be able to use that if we try to run this. Now this instance has changed. Something that I will just want to check to make sure that we're able to log out the execution role. I'm going to make sure that SageMaker is there too. So that's there. Also, we will want to run this again just to make sure that we can run this again. Actually, that'll probably just clear out the error. Yep. So then we have the execution role. We've logged that, and we want to make sure that we can use that later on. So that's great. And we'll also make sure that our image is logged again. So this is giving us some errors, and need to upgrade the SDK. So what we can do is that we can run this here. Something that we could do is we can add that script right below. So add that here. So you'll see here that we needed to install that again. And then let's try to run this one more time. Cool. So that seems to be working now correctly. And now if we try to, again, run this again, we see that the instance is logging this correct instance for our current way that we want to deploy our model. So that's great. So now what we're going to do is we're going to, now that we've confirmed the correct SageMaker instance requirements being met, now we're going to confirm the required instance type is met for the kernel. So this is, for instance, requirements are met for SageMaker session. Now we're going to want to do is confirm requirements met for kernel. So what we'll do is that we will import JSON. Again, we will do, so we're going to create a function called get instance type from metadata. And what we're going to want to do is basically make a check to see, and this is if you wanted to write a script to test and make sure that the valid instance is met, we can do that. So what we'll do is we'll do define get instance type from metadata. We'll say with, then will be t ml metadata resource metadata.json as f, and then we'll say metadata equals json load.f, and resource name equals metadata.get resource name, and then we'll say return resource name, and then we'll define a main function here. This will take resource name, and that will be from our get instance type from metadata function. So we can just copy that from there. And then we're going to list valid instance types. So valid instance types equals 3 of them. So we'll do ml g5 12 x large, ml g5 48 x large, then we'll do ml g5 48 x large. So we're just trying to make sure that we're using specifically this one, but you could use these other ones, and you can see if these other ones show up in that blog post. MLG5 48x large. Yeah, so this is just with periods. These are with hyphens, but yeah, that's the other type of instance that we would be looking at. And then yeah, we could probably see, yeah, we could probably just remove one of these. Cool. And then if we're just checking the valid instance types here, we'll do if any instance type and resource.name for instance type invalid instance types. Print instance configured correctly. Otherwise, else print need to upgrade to at least ml g5 12x large instance. Cool. And then we will define this next to definition. We'll say if name equals name, then we'll run our main function. So give this a save. Let's see if we can run this. And that makes sense because we already have this running. So we are using our G512X large instance. We know that that's there, but this is just a function that you could run or a script that you could run to check and make sure that your instance is configured correctly. And you could use stuff like this for test-driven development. Make sure that you have a test. It's checking the instance type before you run anything. Okay. So now that we've checked all of the initial parameters, we'll give this a save, and then we'll be able to go to the next step, which will be deploying the model to Amazon SageMaker instance endpoint. So now for the fun part. So we're going to deploy Meta's LLaMA 2 model to Amazon SageMaker. And this is going to be a markdown text file. Okay, cool. So when we're deploying this model, we're going to need to do several things. So first of all, we're getting provided this specific LLaMA model through a Hugging Face container, which is at DLC. And we're going to be deploying that into Amazon SageMaker Studio. So with the accompaniment of the SageMaker Python SDK. So we're going to create this SageMaker endpoint that's going to host the deployed LLaMA 2 model. And that's going to allow us to make inference requests to the model to do text generation in a like ChatGPT interface manner. So we're going to be doing a couple of things. We're going to be importing some libraries. We're going to import JSON, Hugging Face model, and SageMaker Hugging Face to represent the Hugging Face model for deploying this to SageMaker. We're then going to configure SageMaker within the session. We're then going to configure the model and the endpoint. We're specifically using the Meta LLaMA 2 13 billion chat HF for Hugging Face model. We're then going to check the Hugging Face hub token. We're going to pass that token in when the script runs. We're going to create a Hugging Face model, and then we're going to deploy that model within SageMaker to a real-time in-service endpoint. So once this is run, SageMaker is going to get right to work to start the deployment process, and it's going to create an endpoint and deploy that model for us. So this might take around 10 to 15 minutes, and then once it completes, you'll be able to have this live running SageMaker endpoint with this model to then start making requests to your own LLaMA 2, which is going to be really exciting. So the way that we're going to run this script is we're going to start with an import of a few things. So we're going to import JSON. We're going to import this library called getPass, and this is how we're going to pass in the token. So you don't need to write variables inline, or secrets inline. You could get a prompt to pass that in directly. So we're going to import SageMaker. We're going to go from SageMaker Hugging Face, import Hugging Face model. Then we're going to create a function called getSageMakerConfig, which is going to configure our SageMaker instance details. So we're going to call this get SageMaker config, and then this is how we're going to configure SageMaker instance details. So the instance type is going to be MLG5 12x large. Then the number of GPU is 4 for this instance. And then the health check timeout equals 300. Then we're going to configure Hugging Face details. So for this config, this will be an object with some values. So then we're going to do HF model ID. I'm just going to write these down just so that we can add values to them later, but then we'll do SNum. This is max input length. This is max total tokens. This is max batch total tokens. and then Hugging Face Hub token. Okay, so then this is all going to have colons. Oops. And then we're going to call this meta, LLaMA, LLaMA 2, 13 billion chat HF. Then we're going to do JSON dumps number of GPU. Then we do JSON dumps. This is 2048. Total tokens, max total tokens. We'll do JSON dumps 4096. Then what we'll do JSON dumps 8192. And then this we'll use get pass. So get pass, get pass. Enter your Hugging Face Hub token. Cool. So that seems to be all in order. Then what we'll do is we're going to return the instance type and the health check, timeout, and the config. Cool. Now the next function we're going to write is a get for creating the Hugging Face model. So we're going to define a function, say create Hugging Face model, pass in an instance type, pass in a config, pass in a role, and pass in an image URI. So then first of all, we're going to check to see if the token is set, and then otherwise it'll like not allow us to do that because we're going to need that. So check if Hugging Face token is set. So we'll say assert config Hugging Face token doesn't equal 0. Please set your Hugging Face Hub token. Cool. Now, if we do have this value, then we'll create a Hugging Face model with provided params. So LLM, let's call this up. So LLM model equals Hugging Face model, and then role equals role image URI equals image URI, and then env equals config. And then what we'll do is that we'll return that LLM model. Now we will define a main function, and that will be passing an instance type, health check, timeout, and the config. Pass that into get SageMaker config. Then we're going to set role and image URI. So role equals SageMaker execution role LLM image to ref equals LLM image. And then we're going to declare the LLM model with the create Hugging Face model module. So we'll do declare LLM model with LLM model equals create Hugging Face model instance type config role LM image to ref. And then what we're going to do is we would deploy model to the endpoint if LM model is available. So then we'll say if LM model exists, then LM equals LM underscore modal dot deploy. We'll say instant initial instance count equals 1, instance type equals instance type, a container, startup, health check, timeout equals health check timeout. So then what we can do is we'll have an if, so if name equals main, then start the main function. All right, so give this a save and let us see if this will run. So what we would expect is that it's going to ask us for a Hugging Face hub token, and then once we pass that in, it should start to run and deploy this model to Amazon SageMaker. So we'll see if we passed in all of the values correctly. All right, so now when we are prompted to put in our Hugging Face transformer, this is pulling from the get pass dictionary. So now what we're going to do is we're going to go back to Hugging Face. We're going to go to our profile, and I will show you how to create a Hugging Face access token to then do a read off of our access to this repository. To get access to a Hugging Face access token for an account, of course, you'll need to already have a Hugging Face account, which is free. You're then going to go to your settings, and under access tokens, you're going to click on this, and then you're going to then be able to create various different types of tokens. So specifically, you're just going to need a read token, and then you're going to say that this is for LLaMA 2 prod Amazon SageMaker. So this is the specific key that we're creating. We're going to generate a token, and we just need access to read. And the reason why is because when we have this gated model, so we are given access to this model from Meta AI, but we need a way to verify that we have access to read from this model. So if you don't have access to read from this, you're going to get an error. It's basically going to say that you don't have access to pull from this container from Hugging Face. So obviously we're going to want to get access to this model, otherwise we can't use it. So the access token is a way to verify that we do actually have access to use this model and run with it. So we're going to go back here, and we're going to generate a token here. Now what we could do is that in the SageMaker, Amazon SageMaker LLaMA 2 prod that we just got, we can copy this. Now what we will do is that we'll go back into SageMaker, and we're going to paste this in. We're going to press enter, and let us see if there's an error. So it said L image to ref is not defined. All right, so let us now figure out, oh, I think we just needed to make that into a comma. Let's see if that was the only thing that was the issue. Yeah, looks like it. Okay, so now we'll do enter. We'll paste our token in again, and it did not like this. Oh, config is not defined. let us find where that is. So config p. Try that again. Third time's a charm. All right, so now it's reading this token. It is going to be starting to possibly be fetching our access to this model. And then what SageMaker and Hugging Face are going to do is that through this deep learning container, they're going to be providing this model to us and then allowing us to store this inside of an endpoint within SageMaker. And we're defining this with our MLG512X large instance. And we have GPUs set up for that. And then we're just configuring a bunch of the Hugging Face details about the model. And now it looks like it is running. So this is going to inch across the screen while it is working. And we're just going to wait for this to finish up. And as soon as it's done, it should see, an exclamation point, and that will mean that the model was finished creating the endpoint. So now something that we can do is if we go back here, if we go back home, we press on this. So something that we can start to play around with in terms of our deployments is our endpoints. So we can see now that this is starting to create an endpoint for us. We can't actually do anything with this yet, but we do see that this is deploying this endpoint. And when we go back to our notebook, so we'll see that this is starting to inch across the screen. So we're going to wait for this endpoint to finish deploying. This should take around maybe 10 to 15 minutes or so. So I'll bring the video back and we will resume when the model is finished deploying to the endpoint. All right, so that was insanely fast. So this was really under 10 minutes being able to get this spun up. So now what we're going to do is we're going to check to see if the endpoint was configured correctly. So we can go back to endpoint. We can go to refresh. Ooh, and look at that. So now we see that this is in service. So that's great. So now what we can do is we can go back to our notebook. And one of the things that we can do is we can retrieve endpoint information. So something that, we could do if we wanted to do was we could write a script to get the endpoint, but really all that we need to know is that this is the name of it. So this is the name, and then we're going to be able to pull from either this, or if we click into it, we could get the ARN, which is right here, and use that, in Lambda, in API Gateway, in AppSync, whatever we need to do, we'd be able to pull from this endpoint. As long as we are within our own AWS account and environment and those types of things. But what we're basically deployed was a all traffic instance endpoint. So this is where it's running on that that instance that it's in service, meaning that it's on. It was last updated 2 minutes ago, but this is our endpoint. This is our LLaMA 2 model, and we're able to hit this endpoint and get responses back through requests. So now what we want to do is let's start talking to our model. So this is something that is really, I think, also the really fun part too, of being able to then start messaging and doing prompting to the model. So let's start doing that. So what we'll do is that we will start here. We'll say attempt number 1. Speak to LLaMA 2. All right, cool. So what we're going to do is that I'm going to show you one example of one of the ways that we could prompt. And this specific one, I'm just going to give you a little bit of a hint that there will be a limitation to what this can do. And maybe like you can try to guess what the limitation of it is going to be. But it's going to prevent basically something from happening with the prompt. So we'll get a prompt or answer back, but there'll be an issue with it. So maybe you can guess to see what it is. So we'll do import JSON import Boto3. And then what we're going to do is that we're going to create a SageMaker runtime client. So SageMaker runtime client. It's going to be SageMaker runtime equals Boto3 client, and then SageMaker runtime. Cool. Then we're going to define the endpoint name. So endpoint equals, and we're going to pull from endpoint. The name of this is here. And then we're going to create a build LLaMA2 prompt function. So build LLaMA2 prompt message start prompt equals. Then we're going to pass in this s, pass in this instance for insert, space that, and then we'll do end prompt equals space. Right there. And then conversation equals an empty array to start. Then what we'll do is we will do a for loop, and we'll pass an index and message and enumerate message. So if message, and the role in message equals system and index equals 0, then conversation append f quotes, and then we'll do s. This is some some of the prompting from the Meta AI documentation. So this is quite a lot of stuff. Pass in some enters there. And then elif message role equals user conversation append message content dot strip, and then parentheses again, and then last else conversation dot append f. Do this inst again, and then message content strip s inst, and then for is going to be returning start prompt plus dot join conversation plus end prompt. Now for messages, this is going to be really important, so we're going to define a few things in this. Specifically, we're going to define a role. That's going to be system, then content, and I have a prompt here that I'll copy in. Yeah, so I'll read this out, but it says, you are a nonprofit advocate and champion. Your goal is to help entrepreneurs and movers and shakers find their purpose and impact the world positively for the better. So I thought that that would be a really interesting prompt to get some information from Llama 2 about what it thinks about how to help the world. So then we give it an instruction. So the instruction is, what does the world need more of right now? So basically, this is what we define, and then this could be what a user defines or sends. Actually, we could call this requests. Now, the user might submit something in a chat, right, to say like, what does the world need more of right now? And then we in the model already have this persona around the large language model to know how to respond to that specific question taking on that persona. So then when we do messages, we'll then do append, we pass in the role, user, and then content is the instruction. And the prompt equals build llama 2 prompt messages. Now we will define the input data. And the input data is going to give some characteristics about how we want the model to respond. So temperature is going to be important, top K, max tokens, repetition penalty, and stop. So we'll define those. So input data equals an object. And then we'll do inputs, prompt, parameters, say do sample, set to be true, top P 0.6, temperature. So we want the model to be very creative. So say 0.9, top K, we're going to set to be 50, max new tokens 512, and repetition penalty, we're going to set at 1.03, and then stop is this character. Cool. So it seems like that's all the input data that we would need. And then what we'll do is that we'll do input data JSON equals JSON dot dumps input data. Then we're going to set the content type header, and the content that we would want is application.json or application/JSON. So content type equals application JSON, and then perform inference using the model. So do response equals SageMaker runtime invoke endpoint. Endpoint name equals endpoint name. The content type, we have already defined that above, so content type equals content type. Body equals input underscore data JSON dot encode UTF-8 cool, and then we're going to read and decode the response for the user to actually read, so response dot body equals response dot body dot read dot decode UTF-8, and then response JSON equals JSON loads response body, and then extract and print the generated response. So we'll do generated text equals response.json, generated text, and then we're going to print that value. So print generated text All right, so we will give this a save, and we will try to give this a spin and see if this works. So endpoint name, it didn't like that, so endpoint name is not defined. We just called it there, we could call it endpoint name. So it looks like it's running. And the response is not defined. So response. Try this again. All right, so this looks pretty good. So as a nonprofit advocate and champion, I believe the world needs more of the following things right now: empathy and compassion. With so much conflict and division in the world, we need more people who are willing to listen to others. Social and environmental responsibility as the world grapples with this. This is like a very detailed answer. This is really cool. Now, something that I'm noticing is that we're willing to struggle to support others, but it kind of cut off there. So the reason why this is happening is because, and maybe you might have guessed it if you were thinking about that before. So the max new tokens, we can increase this. So we can make this much larger, and this means that we can allow for more tokens to be brought back out of the model and then into the answer. So what we're going to do is that we are going to say cut off characters. We're going to then do another one, and we'll say attempt number 2, or max new characters. Cool. So we're going to copy this same exact prompt, but instead of it being only 502, we're going to do 2,000. So everything else is going to stay the same. We're just going to increase the max new tokens that can come out in a response. So I'll press enter. It's going to be working. Generate the answer. Okay, cool. So now do you see that we're getting this 10th answer about a sense of hope and optimism. So this is important because when we're expecting, maybe longish answers, then this is something where you will need to think about the max new tokens, because this just had 9 and 9 was cut off, and then 9 had a whole lot more to say about that, and then also a 10th answer. So this is great. So now we're able to get more answers and more detailed responses. So this is the type of prompt that will help us accomplish that. Now, I'd love to just like start kind of playing around with some of this type of stuff. So let's do chef asking for a recipe that hasn't been created before. All right, so it's going to be basically the same type of prompt. Now, instead of this, I'm going to say you are a world-class chef. Your goal is to prepare unique, special, and stand out meals, dishes, recipes, and eating experiences that are truly amazing. And 5 stars. Okay, cool. So now let's see, the instruction is, what is a fancy recipe? Actually, here goes your chef. What is a fancy recipe for something with, what would be a good recipe? Whatever it was for, let's say for a modern take on pizza that doesn't exist yet. So we want this to be super creative, so that's plugged up there. All right, cool. All right, let's run this and see what happens. So this is working and thinking, and it'll be generating back a response of some sort, probably pretty soon. All right, okay. Oh, this is really cool. Okay, so as a world-class chef, I'm always looking to push the boundaries of culinary innovation and create this standout dishes that are truly amazing 5 stars. This is this molecular pizza with a twist. So it has pizza dough infused with truffle oil and topped with gold dust, saffron and honey glazed crispy prosciutto, caramelized onions and balsamic glazed figs, goat cheese and arugula pesto, and baked in a wood-fired oven with a side of truffle-infused olive oil. Okay, molecular pizza is a game changer. The pizza dough is infused with truffle oil, giving it a rich, earthy flavor and an air of sophistication. Saffron honey glazed crispy prosciutto is crispy. Oh, the caramelized onions. This, I'm getting hungry as I'm reading this. This sounds so good. The goat cheese and arugula pesto and add a tangy and peppery kick, and the balsamic glaze brings everything together. To take it one next level, pizza is baked in a wood-fire oven, giving it a crispy crust and smoky flavor. Truffle-infused olive oil adds an extra layer of luxury and decadence. This is truly a masterpiece and must try for any foodie. So this literally teaches you how to do that. So it gives you these 9 different steps about how to cook it. So, wood-fire oven, 500 degrees Fahrenheit, roll out the pizza dough and place it on pizza stone. Talks about, spreading the truffle oil around the dough, bake the pizza, serve immediately. I mean, this sounds like this is a real 5-star restaurant. So molecular pizza, that sounds amazing. All right, so let's test the limits of this even more. So let's see if we can do another thing. So let's see if we can say, provide coding snippets for different use cases. Okay, so let's see if it can do coding. This is something that I haven't tested yet, so we're going to see this. So you are a world-class software engineer. Your goal is to write code snippets, functions, algorithms, or whatever is required by the prompter. Okay, so what is a use effect hook in React, and how would I code one? Right. So let us save this, and then we'll run it, and we'll see if it's able to generate a code snippet. So this is going to be interesting to see if it will actually be able to do that. So let's see. Oh, okay. All right. So hey there. As a world-class software engineer, I'm happy to help you understand the use effect hook in React. Use effect is a React hook that allows you to add some side effects after rendering, like fetching data from an API, set up event listeners, update this, but you don't need to be done every time that the component re-renders. Here's an example. Okay, so it's using functional component, it's using use state, and then it uses use effect, and it's using API, that example, with then, and closing it out with unsubscribe, and then it has returns this, so it creates a whole functional component. This is amazing. So now this says it's called after the component renders, and it's fetch data from the API using the fetch function. Okay, this is incredible. Let's try another one. Let's do write a function to reverse a string in Python. And we'll run that, and we'll see what LLaMA 2 comes up with. All right, so simple function to reverse a string. Define reverse string. This is the scope, and what we're going to do is return this. So reverse string hello, and reverse string is this. So just return string and then : -1. So that's how it works. So this is incredible. Let's even like ask it career advice. So let's do career advice. All right, so we're gonna ask, you are a world-class recruiter and career coach. Your goal is to help anyone get a job and help them maximize their potential. Cool. All right. So I am trying to get a job as a software engineer. What is the best way to get an interview? All right, so I will save this. I will shift enter, and then now the model is going to try to give us some career advice. So let's see what it thinks about that. Okay, so this is pretty cool. So it just gave us a ton of information. So I'm happy to help you land your dream job as a software engineer. Here are some ideas: strong online presence, professional LinkedIn profile, make sure it's up to date, connect with professionals in industry, and engage with relevant content to showcase expertise. You can also create a personal website or a blog to showcase your projects and expertise, network and attend industry events, tailor your resume and cover letter, leverage your existing network, reach out to your current, former employees, practice your coding skills, showcase your projects, create a portfolio, and be proactive. Don't wait for opportunities to come to you. Create your own. Reach out to companies that you're interested in and inquire about potential job openings. Offer to do a project or contribute to their open source projects to showcase your skills. You can also research common interview questions, prepare examples, show your accomplishments, be open to opportunities, be open to different types of jobs, including entry-level, internships, freelance, help gain experience to build your network, and follow up. Oh, that's a big one. So after you apply for a job, follow up with a hiring manager or recruiter to express your interest and thank them for considering your applications. You can keep them top of mind, demonstrate your professionalism. And then it says, following these tips, increase your odds, good luck. So this is amazing. And this is our own large language model, completely deployed through AWS SageMaker, and it's able to generate amazing answers and amazing responses. So this is very detailed. And of course, if we were having, a front-end application, we could make the text, a little bit more organized, a little bit cleaner, but it's still the same text. We could just, format it with like a code snippet, like syntax highlighting or, text, to make it a little bit more visual. But this is so amazing. And then let's just close out with another one too. Let's try to do one that's on like financial advisement, or like pretend to be a financial advisor. Not as financial advice, but it would sort of be helpful to think about what are ways that we can, maximize our business prospects. So if you're like a business owner or something like that. So let's say, how can we maximize our earning potential? All right, cool. So we copy this, and then I'm going to take on this role. And this is another prompt that I had from before. So instead of being a role-cast recruiter in this, and also this is totally not financial advice. This is we're just trying to see if LLaMA 2 could give something that looks like financial advice and maybe give some ideas about how to build wealth. So you are a financial advisor. Your goal is to speak with users in a confident, assured, and calm demeanor to help them plan for their finances in line and grow their wealth. Cool. So now, question that we could ask is, what are the best ways for young professionals to retire early? So we'll give this a save, and then we'll give this a run. And we'll see what this says. Oh, all right, this is a lot of good stuff. Okay, so hello there. As a financial advisor, I'm here to help you achieve financial goals. And obviously, it's not a financial advisor, and this is not financial advice. Goes without saying, but just reiterating that this is not financial advice. This is just testing to see if it could take on the role of someone that could be like a financial advisor and speak as one. So here are some strategies to help young professionals do this. So start saving early, live below your means, invest wisely, max out your retirement accounts, pay off high interest debt, build multiple income streams, prioritize your health, and adjust your plan regularly. This is amazing. So this is giving us really in-depth, answers. There's like a lot, looks like there's put a lot of thought to it. Even like creating a budget, subscription services you don't need and cutting those, cut back on unnecessary expenses, prioritize paying off debts. Your health is the most important asset. Take care of it. It can save you money long-term. I mean, this is just absolutely incredible. And this is our own large language model. So now that we've deployed our model, let's say that we need to take down the endpoint because maybe we're going to be deploying it later and we want to, cost optimize or something like that. So what we can do is we can go to the SageMaker page in the AWS Management Console. We're going to go down to Inference. We're going to go to Endpoints. And then we'll see all the endpoints that are deployed within this account. And if you click on one, you click on the right under Actions, and then you could delete it. And then this would delete it permanently. It can't be undone. Of course, if we go back to the script, we could redeploy this if we wanted to, which is up here. So this is when we're deploying it. So if we were to redeploy the script, it will create a new endpoint, and then we'd be able to then use that new name here. So we don't, I'm going to be keeping my endpoint live, but for you, for example, if you just wanted to spin this down. Otherwise, it will be billing $7 to $8 per hour. So it can get expensive depending on what you want to pay and handle. Just do keep in mind that this will be, like incurring costs per hour. So every time that this is running live, this endpoint, this will be incurring costs to your AWS account. So just as a heads up there, be sure to watch out for that. All right, so that was an absolutely epic build. So we were just able to take Meta AI's LLaMA 2 model, the latest, one of the most prolific large language models available right now on the web, and we're able to deploy that inside of Amazon SageMaker and then generate amazing, really detail-rich prompts back about different questions that we had. So we talked about different recipes. We talked about how to have impact in the world and help people. We're also looking at ways to optimize our finances and grow wealth. We were able to ask it coding questions, so different patterns for how to write code. So just super, super cool, very varied answers that we got and very varied questions. So there was a ton of information that we went through. So let's kind of walk through exactly what we did. So what we did was we took Meta AI's model. We took a 13 billion parameter large language model that is hosted within a deep learning container on Hugging Face. We're able to import that DLC into Amazon SageMaker. We're able to set up our SageMaker environment to create a easy way for us to deploy an endpoint with all the right scripts and all the right dependencies and packages and dictionaries. And then we were able to then deploy a real-time in-service endpoint with all traffic for our LLaMA 2 large language model from Meta. We were able to deploy that as an endpoint to then start doing prompts right up to the endpoint. So this was quite a lot of steps, and I'm really glad that you were able to watch this video. I hope that it provided a lot of value for you. And let me know in the comments below what you want to see next. Are there certain areas of AI that you're really interested in and you want to explore more of? Are there certain areas of AI that you'd like to see a full stack build about? Please let me know. I'd love to hear just your experience with this build, and then also with any sort of build that you'd like me to build on the TechStack Playbook. So with that, wherever you are tuning in from the world, I hope that you have a great rest of your day, afternoon, or evening, and I'll see you next time. All right, thanks everybody. Bye.